Hi, so in this short session, I'm going to show you the Polygonica Boolean as used inside MachineWorks. So MachineWorks is a different library to Polygonica. It's specifically focused on the simulation and verification of CNC machine tools. So first of all, just imagine this blue cuboid is a lump of metal on a machine tool. And I'm just going to cut through it using a cylindrical flat end CNC cutter. So we modeled the cutter as a cylinder because it's spinning very, very fast, so it's rotationally symmetric. And you can see as it's passed through the lump of metal, it's cut out a shape, which we modeled here by doing repeated Boolean subtractions. So if I look at it in wireframe, you can see this is a polygonal model, but MachineWorks has suppressed some of the edges of the triangles or polygons or whatever, and it's only showing the actual prominent edges that it feels that are important for a CNC machinist to take a look at. But later on I'll export one of these models into Polygonica and you can have a look at it in Polygonica where you can see all the edges. Okay, so let's just take a little bit of a closer look at what's happening here. So if I just run through 10 operations first, and then I'm going to go, I want to look at the 15th one, so 12, 13, 14, and then let's look at the 15th one. So here what I'm showing you is what we call the swept volume. So we've taken the sort of back half of the cutter and the front half of the cutter at the start and end of the tool motion and then joined them up. So we've created a closed polygon mesh that represents the solid volume of space that the cutter sweeps through during the tool motion. And then, to create the in-process stock model, we simply subtract that from the actual in-process stock. So we do a Boolean subtraction. So there we go. Probably should have done that in a solid frame. So that's that cut actually being cut out of the stock, and there's another one. Okay, so let's look at that on a bigger model or a bigger toolpath, longer toolpath. So I'll just switch it into the polygonal mode. So here you can see, if we look down the bottom, what we have here is a toolpath comprising 227,000 tool motions. So we're going to compute the in-process stock by doing a Boolean subtraction of each one of those tool motions. So that's 227,000 Boolean subtractions. So let me just set that running first of all, and we'll just have a look at it from this side. Whoops, and stop that. And you can see what we have here is a ball nose cutter. So the end of the cutter is a hemisphere with a reasonable amount of facets, and you can see as it moves across the stock, it's removing material and creating a faceted surface. Now the purpose of showing you this is just to show you how fast the Polygonica Boolean can actually go. So you'll notice I'm doing this in single threaded, and I'll just might as well play while I'm talking. It's a single threaded, and we're updating the graphics after each Boolean operation. So after each Boolean operation we have to transfer the stock from the CPU to the GPU, or at least the updated portions of it. I'll just stop that. And you can see it was going through those cuts pretty fast, but I'm going to turn on multi-threaded, and this time we're going to use a multi-threaded processing and also only update the graphics every 1,000 cuts. And you can see, if you just watch here, you can see it's chunking through those 1,000 cuts really quickly. So I don't know what that is. It's probably less than a second for every 1,000 cuts. So that's every 1,000 Boolean operations. It's updating the graphics, and we're doing 1,000 Boolean operations in probably about a second on this stock. So that's how fast the Polygonica Boolean can go. Now I probably should say, if you're interested in building this type of simulation, you're probably better off licensing MachineWorks rather than Polygonica, because MachineWorks has lots of optimizations in it that are specifically for robot simulation, CNC tool simulation, additive simulation, all that kind of stuff. Polygonica is a more general mesh engine where you have lots of different ways of using the Boolean algorithm in lots of different cases. And just zoom in at the final result here, and you can see what we have, really nice cusps, which machinists are interested in seeing the surface quality of the finish. And although this is a simple roughing path, you can see that we've got a really good quality finish there. So finally, I'll just export this into Polygonica, just have a look, see what it looks like in Polygonica. So stop.stl. Okay, and let's load that into Polygonica. Maybe it's still saving it. Oh, great. Excuse me. Sorry, that took a bit longer than I'd hoped. So here's the stock in Polygonica. Again, if I zoom in, you can see we have really nice cusps there. No, the Polygonica demo doesn't use surface normals unless they're provided. So we've just transferred this as an STL. So we're looking at an effectively flat shaded result. And then if I turn the edges on, we can see all the edges here rather than the edges that MachineWorks chose to show us. So you can see the full polygonal result, and as you can see, it's pretty nice. The other point, I don't know if you can see because of the inset window, but down the bottom we've got these traffic lights in Polygonica demo. So this solid that has been created by those 227,000 repeated Boolean operations is watertight, it is free from self-intersections, and it's also manifold. And whilst the Polygonica Boolean engine can deal with can accept and work with non-manifold geometry, in this case we don't have to because it's come from MachineWorks. Okay, thanks for listening. If you'd like to evaluate Polygonica, or you would like to learn more or get a demo from me, then please don't hesitate to get in touch via the Polygonica website where there's a contact form. Thanks for your time.